Hi, good evening everyone. Welcome to the last session of today's summit. And today we'll talk about how you can build a prediction ML model using public data without writing a single line of code. My name is Wei Liang and I'm a solutions architect at AWS focusing on public sector customer. And for today's session, I'll be joined by my colleague Indra, who will be walking with us through the second half of the session, and he'll introduce himself a bit later. So let's get started. This is an overview of the agenda that we'll be covering for this session. We start off by examining the state of the AI and ML and its challenges, followed by how we can scale the ML value creation by empowering the business analysts. Next, an introduction to Amazon SageMaker Canvas with a demonstration of how we can use it to predict the Singapore property price. Lastly, we end the session by having some key takeaways and resources to help you get started. So let's kickstart by looking at some of the challenges that is faced by most companies today. So in the current state of landscape, most companies around the world, in all industries, they want to add AI capabilities to their application, but they don't always have the time or skill sets to develop their own ML model. And our mission at AWS is clear. We aim to put machine learning in the hands of every developer. We do this by making it easier for you to be productive with sophisticated ML services. While AWS offers the broadest and deepest sets of AI and ML services, we often felt that more can be done. And one of the best things that we can do is to enable your existing business analyst talent or to become productive with ML, and specifically developer or business analyst talent. The ML industry has matured to tackle some of the most challenging common challenge in the past, and since 2010s, the industry has been focusing on building ML technology that is traditionally done by data scientists or machine learning engineer because of the high learning curve. Afterwards, we see a trend of easing the ML adoption to allow the data engineers to be able to do some ML experimentation, such as testing which models will work best, and also productionalizing the model. Fast forward to the present, we focus on bringing the ML mainstream by empowering the business analysts with an easy-to-use interface and simple language to offer explainability, true feature importance, and advanced metrics that is easy to understand. And if we think of the ML development process as a funnel, we often have the business team generating a lot of creative ideas at the top, while collaborating with the ML teams who is focused on delivering the value at the bottom. And there's often quite a significant imbalance in resourcing as we move from the top to the bottom. And it's not uncommon to see a ratio of business analysts to data scientists of around 20:1. So with this resource constraint, in the ML team, we can only test so many ideas at once. And so in order to scale the ML value creation, we need to widen this funnel so that we can test more hypotheses, generate more value, and let's look at the 3 different ways to do this. First, you can increase the productivity of the ML team by giving them the tools and platform that they need. On AWS, we have this service called the Amazon SageMaker Studio, which provides a unified platform for the ML teams to perform all the ML development steps in a single pane of glass. The second option is to scale the existing ML team that you currently have, right? To increase the size so that you can meet the demands that is coming from your business team. While this sounds like a pretty nice solution, the demand for AI and ML team skills have grown over the last few years, and given how new this field is, it's not surprised that there's just not enough talent out there to meet the market demand. So what else can we do? The third approach is to tap into the business team that your organization that already has and help them to build and use their own ML model. If we could democratize the development of machine learning models with a completely no-code experience, our business team who already has the rich domain expertise, they could quickly tap into the power of ML and generate more value on their own, This approach will allow for more ideas to be tested without having to scale up the ML team. Let's have a quick understanding of the process of developing a machine learning model, which usually consists of 4 key steps. The first step is to understand the business requirement and to be able to frame the problem as a machine learning problem that is able to unlock your business value. So we look at things like identifying risk patient, or even predicting customer churn rate, or predicting new business as well. The second step is when the data engineering team will need to source the data across different data sources, join them, clean them, and start the initial feature engineering process that is appropriate for the problem. You will then move ahead to step 3, where you will decide which algorithm to use for experimenting to tune the parameter to get the best result out of the algorithm. This process usually entails a lot of iteration of feature engineering and model training. And the final step is to deploy it into the production, to expose it to the business team to predict any new data. As you can imagine, the end-to-end is a lengthy process which usually takes from weeks to months. And so in order to shorten this entire process, we introduce to you Amazon SageMaker Canvas. With SageMaker Canvas, you can generate highly accurate predictions without any machine learning expertise. SageMaker Canvas has a visual drag and drop interface that guides you through the steps and process, and also gives you the explainability that you need to explain your model. Business and data analysts, they can use SageMaker Canvas to quickly connect and access data from different sources, prepare the data for building the ML models. And SageMaker Canvas at the backend leverages on AutoML technology from Amazon SageMaker, which automatically trains and builds your model based on your data set. And this also allows Canvas to identify what is the best model for your problem so that you can generate single or bulk prediction and even share the model with your data scientists. You'll be able to import and join data sets from multiple data sources using a point-and-click UI interface. You can also leverage on built-in visualization to understand the quality of your data and any correlations and to make any adjustment that you might need. Moving on to training, SageMaker Canvas uses the AutoML technology, as I spoke about earlier, to identify what is the right problem type for your use case and to build the best model for you. And what I really like about Canvas is that you don't have to wait for the model training to be completed to get any preliminary insights. It offers a model preview feature so that you can get initial estimates about the performance of your model and the quality of the data set in a matter of minutes. Once you feel comfortable with the model, you can get your predictions right within the Canvas UI. You can choose to run what-if scenarios by changing the inputs to the parameters in the UI, or get predictions for all your data set using a batch prediction method. So with a few clicks and an easy-to-use interface, the business team can now build and use ML, as well as partner with the data science team to productionalize any models that they need. So what we hear from our customers today is that they want to bring machine learning to a number of projects that business analysts can apply machine learning to their analyses to generate any predictive insights. So these are some of the use cases that SageMaker Canvas can be used for. And some examples for public sector includes predicting hospital readmission rate for high-risk patients, or even predicting the property price, which we will show in the demo later. So moving to today's session, which is a demo that we want to show. In our demo, we want to show how we can build a model to predict the Singapore property price. So we look at adopting various personas of like policymakers, property valuers, or even property buyers and sellers who might want to predict the public or private property price based on certain property attributes such as the area size, the type of the flat, whether it's private or public, the floor, whether it's high or low, right, and the lease remaining of the flat, any nearby amenities, and many more. And if we look at the result, perhaps as a policymaker, I can gain insights into the property market and decide whether additional measures are needed for the market. As a property valuer, I might be able to get a rough estimation of the property value. And as a buyer or seller, I'll be able to make a more informed decision of the purchase or sales decision. So for the demo flow, we start by importing historical data sets for the last 5 years, which consists of public and private data taken from the Singapore government website. We will then use Canvas AutoML to train the data, which will then generate the analysis to understand the model and also allow us to predict the new data using the model. Within a few clicks, we'll be able to complete this end-to-end flow. Here is an overview of the dataset that is used in this demo. So it contains the past 5 years transaction data, and we know certain important details such as the floor area of the flat, which will typically correlate with the type of the flat, whether is it a 4-room flat or a private bungalow. We also know where the flat is by using data engineering to call an API to get the latitude and the longitude, which is then used to calculate the distance to amenities like MRTs or even schools. Right? So with this data set, we fed it into Amazon SageMaker Canvas to generate an ML model, which I'll walk through shortly. So to kickstart the entire process, you will first import the data through the Canvas console, where you'll be able to upload the data either through your local machine or S3 based on your preference. So during the import process, you are also able to preview the data as shown in this demo, and if everything looks okay, you'll proceed to import the data. Once the data is imported, it will appear in your list of available data sets, and there are use cases where you might want to join the data set with another data set, right? And in this example, I'll be choosing 2 different data sets to join. You'll also be able to select different joining mechanisms, such as an inner join or outer join. And SageMaker Canvas is smart enough to know, to understand what is a unique identifier based on the data set. So now I have my final data set, which I will name it as Singapore Full Housing Data. With the data preparation complete, I can now move to the next stage by creating a model, which I will name it as Singapore Housing Regression. Next, from the console, we will proceed to build the model where there are different parameters that we need to select. First, the target column of the prediction, which will select the price of the flat. Next, we will select the model type for our particular use case. And because we are predicting the flat prices, we'll be selecting the numeric model type. We will then be able to see some nice visualization of the data using the console itself. We can see the distribution of the data of a particular column by hovering your mouse over it, such as the distribution of whether the data is a public or private flat, the distribution of the floor, the flat type, and so on. We'll then do a preview of the model, which generally takes up to 2 minutes, and it will give us an estimated root mean square error, which tells us the standard deviation of the prediction error. We are then able to also scroll down the preview to see what columns are less impactful so that we can remove them before the actual build. So in this case, I'll proceed to drop the school column. And then before I will go ahead to do a quick or a standard build. So the quick build actually takes about 2 to 15 minutes, but it only allows a maximum of 50,000 rows for the input data set. And in our case, because we have more than the maximum rows, we will choose a standard build, which normally takes about 2 to 4 hours, and Canvas will maximize behind the scene to find what is the best model for me. I'll fast forward to when the build is completed, and this is the analysis of it. Again, you get the model status of it, which tells you the deviation from the actual value for the price. The number seems a bit higher because we have a joint data set of the public and private housing, which the prices can be very different. You can also view the scoring and advanced matrix so that when you speak to your data scientist team or your business owners, this page actually helps to explain the prediction and also how well the model is performing. Here is an example of a mean absolute graph, which gives you the mean absolute difference between the model prediction and the target value, where the lower the better. You'll also be able to view the error density graph that shows you the shape of the distribution. The last step is to do a prediction within the Canvas UI, and you can choose to do either single or batch prediction. In this example, I'm choosing a data set that I have uploaded previously, and once the data set is selected, Canvas will proceed to generate the prediction. Once it's ready, you'll be able to preview or download the prediction data. And then in this preview section, you can see the predicted price that is located at the first column of the table. Alright, that's the first part of today's session. I will now hand over the session to Indra, who will walk us through the second session where he explained a bit about the expanded use cases. Indra, over to you.
Thank you, William. So hello everyone, my name is Indra. I'm a solutions architect at AWS. So in my role, I help public sector customers with their journey to the cloud. So you have seen from William's demo earlier, using SageMaker Canvas, it is very easy for business analysts to generate machine learning model and get prediction without writing a single line of code. So we also made it possible to share your ML model generated from SageMaker Canvas with your data science and machine learning engineering team. They are then able to validate the code and even fine-tune the model to get a more accurate prediction result. So this is very important, and we put a huge emphasis on having model transparency, because only by having a fully open and transparent model, both business users and the data scientists will then be able to trust the prediction result that is generated by the model. So let's see how this works in detail. Continuing from where William left off, so once you have the model ready to share it, it's as simple as choosing the model version that you want to share. And then you click SageMaker, create SageMaker Studio link, and then a shareable URL link can be shared with your data science team. This is what you see, is the SageMaker Studio interface when data scientists open up the link. So right at the top, you see high-level details about this model, followed by a graphical representation of data preparation that was done earlier in SageMaker Canvas. You can open up the Data Exploration Notebook to inspect the data pre-processing codes that was automatically generated by SageMaker Canvas. One example of such data pre-processing, and it's also one of the best practice before training ML model, is to check if there is any overlap between the fields in your data set. So here, from the cross-column correlation chart, we can see that there's no high correlation between the top 5 numeric features. But if you find that if there is any fields that are highly correlated, you can consider removing one of them to reduce model training time as well as to reduce the model overfitting time. So as you have just seen, you have full visibility over the data pre-processing steps that was done by SageMaker Canvas. So here are 50 plus models that kind of like automatically generated by SageMaker Canvas. So clicking on one of the details, we can see the same feature importance as well as the performance matrix as you have seen from Weilang's demo earlier. And on top of that, you are able to download additional artifacts such as the transform training data, the validation data, the algorithm, as well as the explainability report. Another important component that is available for data scientists to review is the candidate definition notebook. So here is where you see details about how SageMaker Canvas evaluates the different model candidates, the algorithm used, as well as the hyperparameter ranges. For example, let's zoom into the generated candidate section. So here you can see the XGBoost is used as the algorithm. One hot encoding is also transformed on the categorical feature, and then before it merges all generated features and applied standard scaling. Once data scientists, they are done validating the model, or they are done fine-tuning the model, they can then deploy this model as a SageMaker inference API endpoint, which can be called by your existing business applications. So I'll show two examples right after this. The deployment is as simple as naming the endpoint. So for this case, we'll name this endpoint as Singapore Property Prediction Endpoint. And then you need to choose the instance type that is used to host this endpoint, followed by the number of instances that you want to run. And then you can click deploy. So with this property price prediction API endpoint deployed, you can then integrate it with your existing business applications. I'll show two of the many possibilities. So first, you can integrate the prediction API endpoint with a dashboard that is created using Amazon QuickSight. Second, you can integrate it with a chatbot application that is built using Amazon Lex. So let's start with the first example. Now, traditionally, to get a prediction result from ML models into business intelligence dashboard requires a lot of manual effort, especially during the data preparation step. But with the native integration of QuickSight and SageMaker, this can be done easily using a point and click interface and a simple configuration. And then once integrated, all your analysts will then be able to use this ML model to generate and build predictive dashboards. So let's see this in action. Let me orientate you with this Singapore property dashboard that we have created using QuickSight. So starting from the top left corner, we can see an overview of the number of transactions by town, as indicated by the box size. The darker the color indicates that that particular town has a higher resale price relative to the other towns. So if you click on one of the towns, for example, Woodlands, the map will zoom into Woodlands area and then show all the property locations in Woodlands. One of the most commonly asked questions is that, does higher floor actually translate to higher resale price? So from this chart here, we can tell that that is actually true. Next, we can see that property size between 1,000 to 1,250 square foot is most commonly available in Woodlands. And then the price distribution box plot chart actually shows the min, max, median, first quartile and third quartile of the projected price. And then last but not least, we have a table that shows the row by row property transaction details. Next, I'll show how easy it is to integrate the prediction API endpoint with QuickSight. So what business analysts need to do is just to choose the model endpoint that they want to connect to. And then after which, they'll need to upload a JSON schema file. So here's how the JSON schema looks like. Essentially, it defines the input fields and the output fields that the endpoint expects. And then you also need to define the type of instance that you will use to run the prediction model. Once you have this JSON schema file, you can then upload it to QuickSight. And then next, you'll be able to map the fields from the schema to the fields in QuickSight. And because both sides, the fields names are the same, they are all automatically mapped. Review the output, and we are done. So QuickSight at the back will refresh the data. It will call the prediction API endpoint through a batch job to get the property price prediction. With that initial setup complete, all your analysts will then be able to use this price prediction in their dashboards. So it's as simple as dragging it to the chart. you change the default aggregation from the default sum to median, and then after which you can change the color to follow the overall dashboard color scheme. You repeat this for the relevant other charts, and then once you are done, you publish it as a new version of the dashboard. So now we have both the actual transacted price as well as the predicted price from the ML model. And now with these two information together side by side, you can easily analyze whether or not this property is overvalued or undervalued. So to sum up, business analysts can use ML model from SageMaker to create a predictive dashboard in QuickSight. These new insights can then be quickly shared with the broader business stakeholders so that they can will benefit from this for their day-to-day decision making. Let's take a look at another example of using this prediction API in a chatbot that is built using Lex. So Lex is powered by the same conversational engine that powers Alexa. So it provides high quality speech recognition as well as language recognition capabilities. Now let's ask the chatbot to get a price prediction for a public property. So users will choose the property type, public property, the flat type, and then enter the street name. So for example, Tampines Street 81. Enter the area in square foot, 721, low floor, high floor, and then finally the year the property was built, 1987. So all these inputs will then be passed over to the prediction API endpoint, and then it will generate the prediction in real time. So here we can see that the predicted price for Tampines Street 81, 3 rooms flat, 721 square foot, built in 1987 is estimated to be 381,000 Singapore dollars. So we can also use this same prediction API endpoint to predict for private property. So same thing, but for this case, we'll choose private property, a condominium, enter the condominium name, reflections, capital B, enter the area, low floor or high floor, followed by the property, when this property was built. So similarly, we can see that the predicted price for reflections at Keppel Bay is estimated to be $3.1 million Singapore dollars. So let's recap on the solutions that we have seen today. So it all starts from business analysts using SageMaker Canvas to import data, combine data, and prepare data, all using intuitive drag and drop interface. SageMaker will then build, train, and tune several models at the back before choosing the best predictive model so that you can generate a single or batch prediction. You can also share the model with your data scientists to collaborate, share, or fine-tune the model. When the model is ready, it can then be deployed as a prediction API endpoint that can be integrated to your business applications. So an example that we've seen earlier is a chatbot application built using Lex. And then a serverless Lambda function is used to pass the input parameters to to prediction API endpoint to generate that real-time prediction. Moving on to the front end and the dashboards. So that chatbot front-end web application is hosted in S3 serverless hosting. So that means you don't need to worry about provisioning or setting up of servers to host the application. A CloudFront content delivery network is used to deliver the app globally to provide users with a fast, secure, and reliable experience. On the visualization and the dashboard side of things, that is built using QuickSights. And similar to S3, QuickSight is also serverless. So that means that you can get started quickly without worrying about provisioning costly softwares or servers to power it. You can also easily scale to hundreds or even thousands of users, and still it provides that good and consistent performance. Last but not least, we have Amazon Cognito that is used to provide secure user authentication through social media logins or integrate it with your enterprise identity provider using protocols such as SAML or OAuth 2.0. To wrap up the session, there are 3 key takeaways. First, without writing any code, SageMaker Canvas enables business users to import data, process data, as well as to build machine learning model, as well as to generate powerful predictive insights. Second, you can easily collaborate and share this ML model with your data science and ML engineering team. This allows for full transparency and explainability on how the model actually arrived at its prediction. Third, when the model is ready, it can then be easily deployed as an inference API endpoint that can be integrated with your business applications. So we have seen examples such as chatbot and dashboards to provide predictive insights capabilities. So here are some resources to help you to get started. So you can learn more about SageMaker Canvas. You can learn how you can use Lambda function in Amazon Lex to call an API endpoint. If you can't wait to try SageMaker yourself, we are happy to share that our free tier allows you to try SageMaker Canvas for 2 months at no cost. So you can build up to 10 models per month with 1 million cells of data per model. So I'm sure you see this training slide a lot of times today. So I wouldn't go through it again, but feel free to scan the QR code to get more information. So thank you very much everyone for joining us. So if you are interested to use SageMaker Canvas, feel free to reach out to our team and then we'll be more than happy to help you.